Hello, hello, happy Wednesday. Now we're gonna jump right into things because this is pretty simple and quick, okay? We're on day 23 here. It says use the line plot to answer the following questions, all right? So we're gonna use this line plot. Now, as we see, this line plot this information did not give us a table. They expect us to know what a line plot is and exactly how to use it. So for example, if 19 is repeated more than once in a table, then that's how many X's we would put above it instead of just repeating the number 19 on a number line. That's what a line plot basically does, okay? Now, here we're working with number of chocolate bars sold. Ooh, okay. Number one says, how many students sold 22 or more chocolate bars? Now, when we think about 22 or more chocolate bars, remember the bottom says number of chocolate bars sold. So it says sold 22 or more. So we're gonna count how many are in 22, 1, 2. How many are, it says 22 or more. So we're gonna keep counting. We're gonna count how many are in 22, 23, and 24. 22 had 2, 23 had 1, and then we're gonna count 24. 1, 2, 3, 4, 5, okay? So we have 5 plus 1 equals 6, 6 plus 2 equals 8. So how many students sold 22 or more chocolate bars? That would be 8 students. The X's are representing those 8 students. X's all around on this line plot are representing students, okay? So keep that in mind. Number 2 says the most students sold how many candy bars? Now we're thinking about the most students, we're thinking about the number of X's above which number is the highest. And that would be 19. We see that there are more X's above 19 than there are on any other numbers. So the answer for the most students sold how many candy bars would be 19, okay? Number 3 says how many more students sold 19 chocolate bars than 21 chocolate bars? Now, when we take a look at 19 chocolate bars versus 21, because that's what we are comparing, it said how many more, our keywords, how many more tell us to subtract. But before we get into subtraction, we have to know how many students sold 19 chocolate bars versus 21 chocolate bars. So let's first go to 19 chocolate bars. And we have 1, 2, 3, 4, 5, 6. Now, where did I get that number? I'm counting the X's above 19. Now I'm gonna do the same thing for 20. So above 19 was 1, 2, 3, 4, 5, 6. Above 21 is how many? 1, 2, 3. So we have 6 versus 3. Now it says how many more students sold 19 chocolate bars than 21 chocolate bars? We're going to subtract. How many more tells us to subtract? So 6 minus 3 equals 3. Okay. All right, next question says how many chocolate bars did the same amount of students sell? That's what I highlighted there. So we're looking for the same amount of students did they sell. So we're looking at the chocolate bars first to see which numbers has the same amount of X's next to it. That's exactly what it's asking us. It's asking us how many chocolate bars did the same amount of students sell? Students represent those X's. So we're gonna go into our data. When we look at our line plot, we're looking for the numbers with the same amount of X's. We see 17 is in comparison with 20, which is also in comparison with 24 being equivalent. So they have the same amount of X's. So when we go back to our questions is how many chocolate bars did the same amount of students sell? We would say 17, 20, and 24, okay? Number 5, it says, did more students sell less than 20 chocolate bars or more than 20 chocolate bars, okay? All right, now when we're thinking about this question, it says, did more students sell less than 20? So we have to think less than 20. So we're looking for the amount of X's that are less than 20 when we go to look at our line plot. And then if we keep reading on this problem, it says, or more than 20 chocolate bars. So in this case, we're looking at the X's that are less than 20 on the line plot and X's that are more than 20 on the line plot. Are we looking for 20? No, we're looking for X's that are less with the number of students that are less than 20 on the line plot and more than 20 on the line plot. So we're gonna go back to our line plot. And when we look at less than 20, so we're not gonna count 20. The only numbers we are going to count here to look for less than 20, we're gonna count 18, 19, and 17, okay? So we're gonna count the X's above 19, count the X's above 18, and count the X's above 17, okay? Above 19, we have 1, 2, 3, 4, 5, 6. Okay, if I keep going to count X's above 18, we have 7, 8, 9, 10. So we have 10 total for 18 and 19, and that is discussing less than 20. Students less than 20 that brought chocolate bars, okay? Now we're gonna go into 17. Okay, we have 1, 2, 3, 4, 5. So 10 plus 5 equals 15. So to answer the first part is, did more students sell less than 20? So we're answering that less than 20 part. Less than 20 chocolate bars. we're talking about 15 total. That's less than 20. Now we're going to go more than 20. So I'm going to go ahead and erase here so you can see which ones we're on, okay? Now, more than 20, that would be 21, 22, 23, and 24. Now, when we're doing this, okay, that means we're going to count those X's that are above 21, 22, 23, and 24. So let's do that. So above 21, we have 1, 2, 3. And if I keep going into 22, we have 4, 5, 6, 7, 8, 9, 10, 11. So more than 20, going back to our question, more than 20 chocolate bars was 11. Less than 20 students that sold less than 20 chocolate bars was 15. So it said, did more students sell less than 20 chocolate bars or more than 20 chocolate bars? And your answer is less than 20 chocolate bars, because less than 20 chocolate bars was 15, whereas more than 20 was 11. And we know that 15 is much greater than 11, okay? All right, I'm gonna show you guys a quick video and then we're gonna jump right into our next day 24, okay?
Yeah, y'all. A lot of people talking about data. Yeah. Data. Let's get into it, y'all. Okay. Let me kick off this conversation. What's data? Well, that is information, numbers, and facts telling you about something. Yeah. And there's a lot of different types, so let's jump in. Let's go. Data could be the number of kids who go to your school and what their shoe size is. Or it could be info about a thing like a book. What does it smell like, feel like, or how does it look? Okay. These are called an object's property. What you need to know to understand what it is properly. We can use data to get answers, like how many kids in your class are good dancers, or how do students feel about the new playground. There are two types of data. Let's break it down. There's qualitative data, and that refers to an object's qualities recorded in words, and quantitative data that's measured in numbers, like something's height, weight, age, or temperature. Now when you're gathering or collecting data, then you're taking measurements and notes and making observations. And some data you can collect on your own. For example, that plant that you're growing in your home, if you want to know how much it grows each week, take a ruler and measure it, record and repeat. That's data. Yeah, the facts and the numbers telling you about something so you can understand what it is. We use data to learn and answer questions about the world as it turns. That's data. Data, 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 that's data. Data, 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 data. Whoa. Okay, so you want to find out information about a group, like all the students in the 3rd grade. All you got to do is ask them a bunch of questions, and then you got yourself a survey. Ask questions that apply to the whole population. Every single 3rd grader in this situation, say you want to know the average 3rd grader's height. But you can't ask them all, that would take all night. Take a random sample of 3rd grade kids. Random means they have an equal chance of being picked, which means the sample represents 3rd graders as a whole. And the larger the sample size, the more accurate the result. Now, once all your information has been collected, and you have all the answers to your questions, you have a data set. It has everything you need. With so many measurements, it can be hard to read, so we need to analyze it, present it in ways that demonstrate answers to any questions raised. You can organize your data with a graph or a chart. It displays different kinds of data like art, line plots, pie charts, and bar graphs are 3 ways to organize the data that you have. Make sure they have titles. And what else? Let's see. The X and Y axes must be labeled correctly. Make sure that you display the data in a way that tells the right story and what you're trying to say. You don't want to make a graph that makes all the kids laugh. When you're using data, you gotta do the math. That's data. Yeah, the facts and the numbers telling you about something so you can understand what it is. We use data to learn and answer questions about the world as it turns. That's data. Data, 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 that's data. Data, 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 data. Whoa.
All right, now we're on day 24. Number 1 says, what is the length of the ribbon to the nearest whole inch? Now we're thinking about a whole number. Now clearly it's going to show you as you're looking to measure the ribbon that it gave you on that measure, on that ruler here, that somewhat ruler. Okay, so we see that it is 4 inches. Okay, so that's our answer right there. Nearest whole inch should be a whole number. So 4 inches is what we see. Okay. Number 2 says, what is the length of the ribbon to the nearest half inch? Now we see that it has at least gone up to the whole number 5, and it's in the middle between 5 and 6. So if they're asking us for the nearest half inch, that means it's 5.5 inches. Okay. Number 3 says, complete the line plot to show the information from the table. Now, if we take a look at our table, we have ribbon length in inches. Ribbon 1 is 7, ribbon 2, 5, ribbon 3, 9, ribbon 4, 5, ribbon 5, 8, ribbon 6, 9 inches, and then ribbon 7 is 9 inches as well. So when we're thinking about line plot, remember that most common number is where your X's are gonna come from. So if I see the number 7 in there multiple times, maybe 4 times, that means I'm gonna have 4 X's above number 7 on the length of ribbons and inches on the number line, okay? So taking a look at our data that we have, it says ribbon 1 is 7. Now what we need to do is when we're looking to make our line plot, do we see any other 7 inches in our data? And we don't. So above 7, we'll have 1 X. When we're thinking at ribbon 2 and we see 5, the first thing that we want to do is look to see if there's any other 5s in our data table. And we see 1 other 5. So that means there's 2 5s. So above 5 on the number line, we should have 2 X's. Okay. Ribbon 3, there's 9 inches. So we need to look and see in the rest of our data table if there's any other 9s. Okay. So we have 1 9. All right. In ribbon 6, I see another 9. And then in ribbon 7, there's another 9. So how many total 9s do we have? 3. So above 9 on the number line, there should be 3 X's. Okay. Next one, when we're taking a look at ribbon 5 and it says 8, we know that there is 1 8 because we don't see any more 8. So above 8 on the number line should be 1 X. Okay. Right? And that's how we make our line plot. Number 4 says, which links have the same amount of ribbon? All ribbons. All we need to do is look to see which numbers, which length of ribbon in inches has the same amount of ribbons. And that is 7 and 8. Okay. All right. Number 5 says, how many more 9-inch ribbons are there than 5-inch ribbons? Okay. So when we're thinking about this, we're looking at how many more. So we look at the number 9 on our line plot and we see that it has 3 X's above it. We see that it has 3 ribbons above it. Okay. So that's 1, 2, 3. And then it says, how many more are there than 5-inch ribbons? So we look at the length of the 5-inch ribbons and we have 2 above it. So 3 minus 2, because it's how many more is a key term for subtraction. 3 minus 2 equals 1. So how many more 9-inch ribbons are there than 5-inch ribbons? That would be 1, okay? All right, and that concludes our day for today. I'm gonna play a FlowCAD video for you. Enjoy the rest of your day.
Okay, kids, everybody gather around. We're gonna do a line plot. What's that? Well, that's just an easy way to read and interpret data. So let's get some data. How many siblings does everyone in class have? 0. Hold on, let's take a survey and make a line plot. Okay, today we did a survey in my class about how many siblings each student has. We put all the data in a table right here, but it's kind of confusing. I can't see it clear. That's when it's time to draw a line plot. To make one, I start by drawing a number line. That's the x-axis, going left to right. Now get all the data in your table in your sight. And let's find the range that's the lowest to the highest and everything in between. Now start your number line at the lowest, then fill in all the other numbers that you know. It's easy. Once you reach the highest, that's when you stop. Now you've got the range for your line plot. Next, add a label for your number line to show what the numbers mean. That's the number of siblings. So for each student in your class, add a dot over the number of siblings that they've got. Don't stop. Finish with the title, explaining all the information that's vital, like how many siblings students have in our class. That's a line plot we put together real fast. Now you can easily show how many kids in your class have siblings from 0 to 6. Line plots make data easy to read. To make one, a number line is what you're gonna need. Then to represent each item, you place a dot, add a label and a title. Now you got a line plot. Line plots make data easy to read. To make one, a number line is what you're gonna gonna need. Then to represent each item, you place a dot, add a label and a title, now you got a line plot. Whoa, now line plots can show categories also, like everyone's favorite ice cream. Chocolate. Thought so. And they can show measurements too. Let's take a bunch of pencils. Now what we're gonna do is measure them all to the nearest half inch, then put the data in a line plot. It's a cinch. So to find the range, let's do the math. The shortest pencil is 5.5 and the longest is 8, so we take the difference. Yup, the range is 2.5 inches. And to find the most common length, here's another demonstration of a line plot strength. Come on. Find the number with the most dots. Yup, 7 is a measurement that pops up a lot. And if you want to know how many pencils we measured, all you gotta do is add all the dots together. Yeah, that's 27 pencils, and I use one to write these rhymes for this instrumental. So you can have some data in a table or a chart, but a line plot can give you a visual jump start. Line plots make data easy to read. To make one, a number line is what you're gonna need. Then to represent each item, you place a dot, add a label and a title, now you got a line plot. Line plots make data easy to read. To make one, a number line is what you're gonna need. Then to represent each item, you place a dot, add a label and a title, now you got a line plot. Whoa, great job everybody. If you want to do another line plot, we can. Yeah, we can do them all day. Matter of fact, we can do a line plot of line plots.